The Institute for Advanced Manufacturing at the University of Nottingham would like to present the Smart Manufacturing and Reconfigurable Technologies, or SMART, demonstrator as part of the Evolvable Assembly Systems research project. The SMART demonstrator aims to show how a pre-existing off-the-shelf manufacturing cell can be enhanced with a distributed multi-agent control system, allowing the cell to use the information present in the system to adapt and reconfigure itself in a context-aware manner. This addresses the requirement for a batch size of 1, where every product coming out of the cell can be totally unique with minimal interaction from the operator. The example we use is that of customized pharmaceuticals, either producing blister packs of different drugs customized for a given patient, or specially formulated pills for a patient's physiology. Although we ground this presentation in that example, the techniques displayed are applicable to any industrial domain where unique products are required, and the non-value added costs of reconfiguration are to be avoided. The SMART demonstrator is composed of 8 modular stations that allow it to load, fill, test, lid, label and dispatch pots of colored particulate. These pots stand in for the product, and the particulate allows a degree of customization. The stations are arranged in a loop, with containers entering on the right-hand side at station 1, traveling clockwise around the cell, and being dispatched at station 8 in the top right. Each station resource is controlled by a programmable logic controller, or PLC, which handles the low-level hardware control. The PLC is enhanced by an intelligent agent mounted in an embedded computer attached to it. We use Raspberry Pi boards in this example, but the specific type of board used is not a constraint. The embedded agent is first plugged into the PLC and boots up. Each station has its own agent, and the agents communicate wirelessly, so the stations can be rearranged without additional wiring. This screen shows the prototype user interface for the system. The checkboxes on the right-hand side show which station's agents are online. First, we will show a full run of the assembly process. Using the interface, an operator can specify the recipe to be produced by selecting which operations should be used and their parameters. In this case, we have specified a container with no red particulate, 2 loads of blue particulate, and 1 load of yellow particulate. The product should also be tested, given a lid, and a custom label printed on it. Finally, the product is cleared for dispatch. When the agent system receives the order, a container is loaded by the loading station. The barcode is scanned. This uniquely identifies the product and links it to the recipe that has just been received so that it can be tracked through the system. The container first comes to the red loading station. The barcode is scanned at the entry point, and the agent controlling this station can see that there is no task for it to perform on this container, so it passes through. At the blue station, the agent will see that it has some tasks to perform on this container, so it is removed from the conveyor belt and 2 loads of blue particulate are dispensed. The yellow station places 1 load of yellow particulate in the container as requested by the recipe. At this point, the container is to be tested. The testing station knows from the recipe that the container should now have a certain volume of particulate in it. This is tested, and as it is correct, the container is returned to the conveyor belt. The penultimate station fits a lid onto the container, then prints the custom label and applies it to the lid. Finally, the dispatch station verifies that all the other stations have reported that they have fulfilled the required tasks and removes the container from the cell for dispatching to a pallet. Now we will show how the system can automatically recover from production errors. For this example, we specify a different recipe. In this case, a container with 1 load of red particulate, no blue particulate, and 2 loads of yellow particulate. The product should also be tested, given a lid, and have a custom label printed on it before being dispatched. Production begins as before, with the stations performing their required tasks on the container. After all the particulate has been added to the container, we add some more to simulate an error in production. The testing station detects this and rejects the faulty container. A new container is automatically loaded with the same recipe, and the error is logged for future investigation. Our final example will be to show how the system ensures that each station performs the correct task on the product to result in the final correct output. This also provides the capability to completely reconfigure the physical topology of the cell with no additional overheads. We show this by changing the sequence in which the container moves around the system. The process begins as normal. First, we specify a recipe. The container is loaded, then the red and blue stations perform their tasks. Before the container reaches the yellow station, however, we remove the container from the conveyor belt and place it back after the yellow station. When it reaches the testing station, the barcode is scanned and the agent recognizes that not all of the requirements for the product have been fulfilled. It cannot be tested until it has received all the required particulate. This is shown in the debug output of the agent. The container is therefore sent past the testing station and goes in a loop until it reaches the yellow station again. The loading, red and blue stations will all pass on the container because they have already performed all their tasks associated with it. When the container does reach the yellow station, it will have the final particulate loaded into it. The container will then continue on to be tested and given a lid and label until it finally reaches the dispatch station and is released to a pallet upon completion of the whole batch order. Thank you for watching. Please feel free to contact us for more information.